Now that we have Hello World, how do we test it?
Hi, I'm Paul, this is Diane. We are the PC Zombies, and yes, we're finally going to test this Hello World PC so we can move on and add more components to it. What we've done so far, this is a high-end PC build. We put together the motherboard, the memory, the CPU, and a power supply. We put a temporary fan on it because it's going to eventually have a custom water loop. We're going to focus on just the testing today. Before you start spending money on high-end components like graphics cards and SSDs, make sure your base level components work first.
That's wise.
And along the way, I'm going to show you some tips and tricks that you may not know of. Like, for example, did you know your motherboard might already have the testing utility I'm going to recommend already installed?
And testing now can save you money and random crashes later.
We're going to show you how to unlock the advertised speed of your memory. When you first install it, it's going to run much slower than it's advertised.
And if testing fails, we'll show you what to do next.
So let's get to it, Di.
All right. Why are we testing the memory now before we install Windows?
Here's the problem. If your motherboard is bad for some reason and your memory tests start failing, then what you're going to need to do is return that motherboard for a new one. They may refurbish it and send you another one, or they may fix it and send you back the one you sent them. If you decided to buy the Windows that you can get on Amazon for $50 less, that's OEM single-use license, that window keys itself to your motherboard. So if you installed Windows first and then tried to return that motherboard, you got a new one, then the Windows that you installed is only going to work on the one you returned. Microsoft will not let that Windows ever work on any other PC.
It won't.
No, so either spend $50 extra to get the Windows that you can then move to a different motherboard, or expect to lose your Windows license and have to buy it all over again.
Excellent advice. We talked earlier about that free software that's already in your memory. What is it?
MemTest 86. I've been using it for years. Everyone uses it. And the reason they use it is because it's a standalone utility. It runs before you put the OS on the computer. That's nice.
So how do you run MemTest 86?
MemTest 86.
MemTest.
I know. I get caught every once in a while. I say MTest instead of MemTest. I don't know why. It's a hard word to say. First, you go to mtest86.com and you follow the instructions there to download the software and install it on a flash drive. Then you hook your flash drive up to your PC and reboot your PC. It should boot on that flash drive. Now, all that's a lot of work, right? So there's another way you could do all this. If you buy a high-end motherboard like we did from ASUS, we got the ASUS formula. When we run the BIOS, we could just click on MemTest 86 and it will reboot into MemTest 86 and start running the test for you. That's a neat way to do it. Okay, let's show them how it's done, Di. First thing you do is you boot up your computer into the BIOS by hitting F2 or delete as the computer's starting up. Turn it on, Di. Okay. All right, we're in the BIOS. Now, in the case of ASUS, we got MTest in the top right corner. We could just click on it. It even starts running immediately, too. The other option on this BIOS is you could go to Tool, find MemTest 86 in the list, select it, then select Activate MemTest 86, and then it will just launch right into MemTest. It's the same as using a thumb drive.
So what do you do after the MemTest starts running?
Right, when you start MemTest 86, it just starts testing immediately. And the default tests are pretty good. They're worth doing. In fact, that's exactly what you should do. You should just let it run. It's going to do 4 passes on your memory. If you see any errors, that's when you have to start doing something. The first pass is actually optimized to run a little bit faster. So it doesn't do quite as much testing in the first pass. And the goal here is you want to know if your memory has problems, you want those errors to start popping up early on so you can stop doing the test and go fix it in the BIOS. The problem with memory testing, Di, is there's a lot of memory sometimes. We have 96 gigabytes on this computer.
Whoa.
And with 96 gigabytes of memory, testing that every single address in there, all of them work, takes a bit of time. The first test we ran took about 14 and a half hours to test.
Oh, wow.
And that's crazy, right?
Yeah.
But so you let it run overnight. That's what you do. And if you got no errors after 4 passes, you know your memory sticks are good, you know your motherboard's good, and you know your CPU is good. I mean, there are other things that you could do to test that aren't getting stressed in that test. But basic operation works, and that's great to know. It's really neat. Okay, just let me describe this user interface real quick for you, Di, okay?
All right.
Well, first of all, there are 4 passes. Each pass runs 10 different types of tests on your memory. Once you get through all 10 tests, that counts as 1 pass. In the top you see it says pass and test. Those two where the pound signs are appearing shows you how far along you're at. In terms of the pass that you're running, it says we're at about 50% of the way through it. In terms of testing, your test progress starts over for each of the 10 tests. The top left tells you a little about your hardware that you're running on. In this case, the first thing, clock/temp, says that my CPU is running at 5967 megahertz. Doesn't actually show the temperature on my CPU, and that's because MemTest86 is having problems retrieving that from the BIOS of UEFI. But if it could get that information, it will show it to you. So in our case, we have to look on the motherboard. It shows you the CPU temperature every once in a while. In this case, I'm seeing 71 degrees Celsius right now. How hot is 70 degrees Celsius, Di?
Probably 140.
You're getting there.
I just thinking double.
Yeah, well, that's not so far off. I mean, 100 degrees Celsius is 212 degrees Fahrenheit. So that's pretty hot. You don't want to touch your CPU when it's at 100 degrees. The next thing below that, it says memory. It says there's 95.5 gigabytes. That's 96 gigabytes of memory. It's running at 26 gigabytes per second. The RAM info is telling me that my RAM is defaulting at 4800 megahertz. Well, wait a minute. When I bought it, it said it'd run at 6600 megahertz. So what's going on there? Well, the difference is the advertised rate of the memory has to be turned on in the BIOS. So when you first install your memory, it's going to run slower. And that we're going to show you in the next section of this video.
Cool.
In between these dotted lines, Di, is how your CPU is being utilized during the testing. And let's go to the far right bottom line there. It says CPUs started, 16 CPUs, active 1. Your CPU has cores, and those cores read as CPUs to MemTest86. If you look at where it says CPU 0, 1, 2, 3, 4, A, B, C, D, E, F, each one of those numbers represents a CPU. Right below it, under state, where you see the spinning bars, shows you which CPUs are actually running and doing part of the test. Here, let me show you guys a test which running all the CPUs in parallel.
Oh, look at that.
Yeah, you see it now, Di?
Yeah.
It's got 16 CPUs running, 0 through F, and they're all running at the same time. And guess what else is happening? The CPU package is getting hotter.
Yes.
We're getting up into the 80s now. And in fact, in some tests, it's going to get all the way up to 99, and you won't see 100. And the reason you won't see 100 is because your CPU, in my case, is going to throttle. And it's going to throttle it back down, slow it down a little bit in order to run. When you got all CPUs running, it runs a ton faster. You could go through all 4 passes in about 3 hours. And that's awesome. So that's worth knowing. All right, Di, why don't you interpret the bottom part of the user interface?
Well, the first part tells you that how long you've been to testing.
Right, time. And pass, 1 of 4.
Yeah, 1 of 4, and how many errors you have.
Yeah.
But doesn't it show errors here too?
Yes, we'll get into that next. Why don't we talk about how you actually go through the process of testing your memory, optimizing your memory to run faster, and then what you do when you have errors.
You mentioned earlier that the memory isn't running at full speed. How do you get full speed?
Full speed is what your memory is advertised as when you're buying it. Remember in our memory video, we talked about how to pick the best memory. We were showing that it's not just about the megahertz, but it's also about the latency. And so when you buy your memory, in our case, we paid for memory that would run very fast in terms of the fetch rate. And now we want to run it at that rate. So we put the memory in the computer, we did Hello World, we ran the memory test, it's running at 4800 megahertz. It's supposed to be running at 6600 megahertz and with some latencies that are pretty fast too, so we can get the best performance. To get that performance, we have to turn that on. In the case of Intel, there's a thing called an XMP profile, Extreme Memory Profile. And the Extreme Memory Profile is a set of instructions that your motherboard can get and tell the computer to run the memory at a higher rate. So it sets all the parameters in the BIOS for you automatically, so you don't have to manually set 6600 megahertz by hand. And by the way, if you have an AMD processor, it has a very similar thing that's called an EXPO profile. EXPO, right.
Okay.
And when you're running an XMP profile, you're actually overclocking the memory. So the way you do that in an ASUS BIOS is you go to the Extreme Tweaker page, which is the overclocking page, and you look for the AI Overclock Tuner. Normally, it's set to auto when you first get in. See that? We could change it to XMP1. It takes the major settings, like the 6600 megahertz. For the minor settings, it uses what works for the rig that you have, because your motherboard's going to be different than your CPU and your memory sticks. So this is nice because it pre-optimizes it, and that's the one we're always going to use. If you choose XMP2, what you get is you get the exact profile that your memory stick manufacturer used to test the memory originally. Your best performance will probably be to pick the ASUS XMP1 profile. Like I said, that's what we're going to use. When you exit and save it, it'll list all the little changes it made. It's changing an awful lot of settings to make your memory run faster. And now reboot, and when the computer reboots, it's going to be at the faster speed. All right, let's wait for that to happen. We're not going to make you wait. Video. Okay, here it is. We're there.
It's magic.
It is. It's always magic. Right. Now that you've rebooted, we can run the memory test. So let's go run the memory test and see how it works with the new profile. And now we're running MemTest 86, and look at it here, Di. See, it's running at 6600 megahertz.
Oh, yeah.
So now we have it running at full speed. Remember I said that it does 4 passes, and the first pass is a quick pass. Hopefully the first pass will show us if there's any errors. So let's let this run for a little while.
Oh, there's a setting.
Look at that. We got an error. So let's talk about what you do when you have an error. Ask me.
What do you do when you have an error?
That's perfect. We'll use that in the video.
Yeah, all right.
Okay, so if you get a failure and you've already got success with your memory the first time around, which we did when it was running at a slower clock speed, quit the test and boot back into the BIOS. Okay, we're back in the BIOS, Di. Go back to the Extreme Tweaker. Now scroll down until you see DRAM frequency. See that? Select it and find the next level down. Right now it's set to
6600 megahertz, right?
So let's go to the next lower option available, which is 6400 megahertz. Now let's save this and run the test again. Okay, we're back and we're running the test.
So are you going to just assume that the errors are because you can't run it at full speed?
It would have had errors at a slower speed, which we already confirmed it didn't.
Okay.
At the normal speed. So when we go to full speed, we're starting to get errors, but we're also pushing it at the very limit of what the memory can do, which is also pushing your CPU's memory controller to its limit and your motherboard. And so it isn't always guaranteed that it's going to work with your rig. So if you lower it down 1 or 2 notches and it works, you're probably fine. And in our case, what we're going to do is when we get that custom water loop in and we have real cooling, we're going to try this again. We might get those numbers. But that's the thing about overclocking. There's no guarantees. You do it and you hope you get it. But the memory's rated that it has been able to do that before. So we know it can do that, but we don't know if it can do that on our rig. So now let's set it running and we'll come back and tell people what happened, all right?
All right.
Okay, we're back, Di.
All right.
Do you know you're back?
Yes, I know I'm back. I'm back.
All right, now let's see what happened. This time it passed. Here, let's show them. It passed. Here's what the stats show. It took 13 hours, 45 minutes to run. It took 14 hours and a half when it was running slow. Let's now go in and run it in parallel processing mode, see if it could pass that. I'm going to go to CPU selection and select parallel all CPUs. Okay, now it's running 6400 megahertz parallel CPUs. So let's let this finish and we'll come back and show them how it works, all right? Okay, Di, I pulled Di in here. We're at the very end of the 4th pass. It's been running great. We're at 98% on the last test. When that hits 100, this whole thing will pass. We've had 0 errors. It's only been 3 hours with all the processors running with 64 megahertz memory setup. We know our memory's good. We know our motherboard's good. We know our CPU's good. There could be things wrong with it still, but we know the basics all work. Pass. There we go.
Oh, I love that.
That's awesome, isn't it?
Yes.
Yeah. So now we're all good, all right?
All right. So we passed.
Yeah, we're
No
done.
issues with the memory. That's awesome.
That is awesome. So thanks for watching. Please stay tuned. We're going to start putting together the rest of this computer next. We're going to put the SSDs in. We're going to put the OS in. We're going to tell you some secrets along the way.
And we appreciate you watching, and we appreciate the comments, and we love the thumbs ups.
Thanks, guys.
Thanks.
Bye.
Bye.